still something going on. We must be very close indeed to the question, what is life? The theory applies no matter what anesthetic agent is used. With the dentist's laughing gas, nitrous oxide, we also get a quick stop. And in time, full recovery. Anesthesia by electric shock is known, but never used on man. It is too dangerous. The electrical setup is a little complicated, for we must know voltage and amperage. The electrodes are of platinum wire, which are now being put into position. 30 volts are first administered, but the shock is insufficient. You see the electrodes coming into place. Now the upper one, and now the shock. 60 volts produce complete anesthesia with little injury. You will note that there's no streaming anywhere now on the picture. But there's no permanent damage. You get full recovery a few moments later. Let us see what a higher voltage will do. This isn't anesthesia, it's electrocution. I have done much work on toxicity, observing the effects of poisons. Here is what sulfur dioxide does to protoplasm. If anesthetic agents gelatinize protoplasm, stimulants should have the opposite effect, and so it proved. They liquefy protoplasm. The protoplasm here is literally pouring out into the surrounding medium, going into solution. All continuity in structure is lost, and of course that means death. Theobromine is a close relative of caffeine, a stimulant, and it too disintegrates protoplasm. As before, the slime mold is going into solution in the surrounding water. So you have two pictures. On the one hand, anesthesia and solidification. On the other hand, stimulation and liquefaction. As this curve depicts, normal protoplasm lies between the liquid and solid states. The solidification in anesthesia is not coagulation, for that would mean death. You cannot unclot blood, or as the chemists say, you can't unboil an egg. Anesthetized protoplasm gelatinizes and becomes quite firm. If the gelation goes too far, death by coagulation results. At the one end of the curve, we have liquefaction, and at the other end of the curve, solidification, which in both cases can result in death. In order to test the theory, I tried heroin, and this was a surprise. I'd always thought morphine and heroin to be depressants, and so I expected the protoplasm to gelate, to become firm. And when we saw this, we thought our theory would fall, until we got hold of Goodman and Gilman and read some 5 pages telling us that the opium derivatives are stimulants, not depressants. So the reaction which you see here upheld my theory after all. An extraordinarily interesting problem is the fusion of 2 droplets of protoplasm. Now, egg and sperm readily fuse, whereas 2 amoebae can crawl all over each other, but they never fuse. 2 drops of slime mold protoplasm frequently go together, but when and why they do, and when and why they don't, is a problem. Sometimes they go for each other in a big way, as you see here. And sometimes there's merely a caress. They touch each other and retreat. But after all, a caress may lead to complete union. And then the protoplasm fuses with absolute compatibility. It's important that the direction of flow in the 2 cases should be synchronized. One or the other must give way until we have a wholly harmonious flowing together. Frequently, 2 plasmodia will gaze at each other literally for hours on end, as those 2 did, and then finally cross at one point. Once they decide that they like each other, then the fusion is complete. Notice between these 2 you have a strip of no man's land where fusion never occurs. It took quite a lot of thinking to understand why that should be true. But I believe there's a toxic substance secreted that fills in that space, and they simply won't cross each other's toxic area. We come now to one of the greatest problems in biology. What makes protoplasm flow? To say it is life is no answer. The biologist wants to know the physics and chemistry of protoplasmic streaming. I had an idea. Perhaps the outer layer of protoplasm pulsates and pumps the inner substance just as does the human heart. Here is my proof. What you see is the same protoplasm, but now speeded up by time-lapse photography. The rhythmic period of the pulsation is, as one would expect, the same as that of the rhythmic flow. Here's a primitive heart, 1 drop of protoplasm pulsating out, in, out, in. If the theory is a really good one, it should fit all cases. I therefore studied chaos, a giant amoeba with many nuclei, and hunted for rhythmic pulsations. I speeded up the photography, but still no evidence of a rhythm. Rhythmic movement, but not rhythmic pulsation. At least we couldn't find it. The theory is an excellent one.